Hello, everyone. Welcome to the binary episode of the podcast of the week. I'm Spectre, with me is Z. Today we have the OpenSSL bug that gained a lot of traction on social media, or rather two bugs, a Java XML signature verification issue, and an in the wild chain for Samsung phones. Before we get into anything, though, I do want to mention we'll be doing the DEF CON talk watch party streams this week. That'll be on Thursday and Friday at 6 p.m. Eastern, 4 p.m. Pacific. And of course, we'll cover the Spot the Vuln solution, which I'll let Z get into.
Yeah, so this week's Spot the Vuln is a little bit more complex than some of the last ones, at least if you're looking at it. Main reason for that is I took this out of some actual code from a vulnerability in curl that was reported at the beginning of October. Uh, Made it a little bit smaller, making like that macro a bit more complex than it was in reality. Uh, Basically what you've got here is some loop that's iterating over a buffer. Buffer does come from the attacker, this netrc file, or possibly from an attacker. Um, Comes from there. Basically, it iterates over that, reading it. Key things that it does. First thing, as part of that while loop, is it's iterating kind of line by line. First thing that does while is space. It skips over all the space characters. Looks for a common character or looks of the first non-space is the null byte, and ends it off there. And then at the end, at the end of the portion I've included here, at least, it's checking for a double quote. If it's a double quote, it's going to try and read out like the whole string. Um, Otherwise, if it's not a quoted string, then it's just going to look for the next non-space character, expecting there to be a space character to mark the end of like that word or term or whatever. Key thing there is in that last loop, well, if it's not a quoted string, is it's going to do this is space macro, just kind of keep repeating that and pushing the buffer forward. And that is space macro will check for, the space character, tab character. It'll check between the new line and carriage return character. So that also includes like a vertical line tab and one other character in there. Basically checking for the new line characters. What it doesn't do is it doesn't check for the null, which means it can go out of bounds and then do this zero right afterwards. Actually exploiting this, it's probably going to be a little bit complex depending on the memory layout there. But it is an out of bounds right. It is something you can notice there. Actual exploitation would be, or might be, a little bit tricky, just given the fact that it's going to depend, the write is going to happen, or it's going to depend on the actual layout of memory as it's reading out of bounds already. Nonetheless, I mean, I figure it was a good example of that sort of just assuming you've got a certain structure of the data and parsing for it. In this case, assuming there definitely will be that non-space character rather than just the end of the file.
Yeah. And speaking of vulnerabilities that might be questionable when it comes to exploiting them, we'll jump into our first topic here, which is an off by one in OpenSSL's punycode handler, which yields edit bounds right. This particular page we have open, this GitHub repo, only talks about the off by one issue. There was actually two vulnerabilities addressed in OpenSSL 3.0.7. The other one also being another buffer overflow in X509 cert validation. And I'll let Z get into this one.
Yeah, there were the two issues. I've just pulled up the official like OpenSSL advisory, which kind of talks about both of them first. Effectively, the one that we're going to talk about was one that was initially rated critical at first, and then there was a second vulnerability. I believe it talks here where basically you could end up writing an arbitrary number of course, it's the period character, so trying to control F for that on screen if you're watching doesn't really help. But you could write an arbitrary number of period characters out onto the stack buffer, going out of bounds, overflowing. The more interesting vulnerability, I thought at least, is this a CV 2022-3602, which is in the punycode parsing. I guess both of these are actually in punycode parsing too. This one is morphin off by one. And let me actually bring up code itself. It's pretty obvious. Well, not a pretty obvious issue, but it's one of those common issues where it's an off by one because it's checking this if written out is greater than the maximum output. So as you'd guess, written out is how many bytes it's written out. Max out is size of the buffer, how many bytes it's allowed to write out. If written out is more than the maximum, then it's going to return. Key thing there being if it's more than, not more than or equal to the maximum it can write out. So it'll write one beyond what it should, letting you do a 4-byte integer, write a 4-byte, one extra 4-byte integer out.
And that is on the stack. Just
yes,
I don't remember if you mentioned that.
No, I don't think I did. Yeah, so this is in OSSL punycode decode. And that is only reached through one path, which basically passes in the stack buffer. So with just the one path getting there, like in theory, this could take other buffers, but as it's being used in OpenSSL, there's only the one path. You could also, this is an exposed function, like it's part of the library, so like it could be called in some other application another way, but within OpenSSL itself, this is basically just the one path to it.
Yeah. So it is like an out of bounds right on the stack of 4 bytes. It is worth noting the exploitability here. It basically seems impossible to exploit. So the person who wrote up this GitHub repo tested this on various versions and various operating systems and found that basically in every case, the out of bounds write would be happening into stack padding. So it's not really giving you anything useful. On top of that, whenever you have these out of bounds right on the stack, stack canaries are obviously a factor to consider, and in many cases they will be compiled in. You also have ASLR getting in the way, so even if you could potentially hit something useful, you might need to chain with another bug. And on top of that, as Blika mentioned in chat, this bug is only accessible in OpenSSL 3 or higher, or 3 to 3.07, I should say. So that's another mitigating circumstance, because from what I've seen, like having OpenSSL 3 in use seems to be pretty rare. Most systems are going to be running on 2 something. So it seems to be one of those like newer functions. It's not really going to be super easy to hit, and even if you could, because of all the other factors and the lack of control you have over the stack contents, or like only being able to write 4 bytes in a fixed location, it seems like it's probably not really exploitable.
Yeah,
Of course, it's totally possible it is, but it seems unlikely, at least in this case.
Yeah, like it is an arbitrary value out of bounds, 4-byte write. Like that is a reasonable primitive to say somebody might come up with a way to exploit this. I think just at looking at that, what the primitive is, I think it's fair to say it could be exploitable. And that's what OpenSSL did when they first reported the issue and reported this one as critical. It was critical because you're reasonably likely with that sort of primitive to be able to exploit this. In reality, because of where it is on the stack, so in some cases it was overflowing into padding, other cases into another buffer. If you're compiling with canaries, that's going to be another thing. You can compile this however you want. So there are a lot of questions. Belika mentions in chat, it's going to depend on architecture and also the compiler. Absolutely. There's a lot of different cases. So they were kind of playing it safe by marking it as critical. And then as more environments were checked out, they dropped it down to high simply because it wasn't likely in the common scenarios, but not necessarily that it's not likely in any scenario. It's still a memory corruption. Like there is still something there. Another thing to mention about the actual route to hit the issue is that this happens after the initial certificate chain and signature checking. It does all of that. So it still needs to pass all of those checks. So if it's self-signed or something, you can't even hit this. It does need to be a signed certificate, and then the one of the intermediate certificates has to have a name constraint on it, and the actual like attacking certificate, leaf certificate in that chain needs to have one of these subject alternate names that has a punycode in it, and that intermediate certificate also needs to have the punycode as part of the name constraint. So there are a lot of asks there. there might be some scenario where people are dynamically creating the certs and all of that, but yet still having restrictions on there. So it's not like Let's Encrypt or something's going to give you this. There could be some complex setup, probably like I'd imagine like an internal corporate environment could possibly have it. But actually reaching this in the wild seems like a bit of a stretch, I think, for a lot of cases, adding on to the
Yeah.
fact that there's a challenging exploit to it.
Yeah, there's
And
a
of
lot of
course,
mitigating factors
yeah.
for this. Yeah,
eh,
I wanted to add on there too. Oh, sorry if I cut you off.
Oh,
I
go
just wanted
ahead.
to mention like one other case that the repo that we had up pointed out is maybe if you had like a hosting service that allows customer provided certs, that could be a scenario where this could be exploited. But again, like I don't think I've ever seen that.
Isn't
It
that
would have
like
to be
customer provided intermediate certs, not just like yeah, so
yeah,
customer
sorry.
provided CAs. So
Yeah.
certificate authorities, not just the cert. Yeah.
Yeah, CAs.
I've seen hosts that offer the bring your own cert if you want, but not CAs.
Yeah.
I believe it could happen. I just haven't seen it.
Yeah. Balika mentioned in chat there are many bootloaders that don't use protections and use OpenSSL for cert checks. Yeah, but like the critical thing here is that this vuln is reachable after the cert is already checked. So it's kind of like it's not an attack surface. It's very easy to get access to. So when you can when you add that onto all the other stuff with all the other mitigating factors, yeah, exploitability is looking pretty low here.
Yeah, like
Um,
even on the case of like the bootloaders, you'd have to have your leaf cert that's doing this attack signed by a certificate that they trust on the bootloader.
yeah.
Which, maybe can happen, but I guess you need the two things signed because you do need that intermediate certificate. Presumably their CA doesn't have the name constraint on it. I'm not even sure if you can do
Yeah,
that
there's
actually.
other paths that are easier, I would imagine,
Yeah,
to
but
try to hit the bootloader.
I mean, it's fair to say, like, in terms of exploitability and ignoring the access part of it, yeah, there probably are some cases where it could be exploit, but it just depends so hard on that stack layout for one, which is going to vary compiler to compiler. That's not like stack order is not something that's just defined for the language. It can be whatever the compiler decides, and compilers do reorder the stack. Um,
Yeah, usually against attacks like this though. So,
Yeah, like the
there's
common
that.
reordering is to put the buffers so they won't overflow into anything smaller. So like a smaller or a buffer won't overflow into like integers or some flags or whatever.
Yeah,
Being a 1 byte overwrite, like best case scenario, or not a 1 byte, being 4 byte overwrite or integer overwrite. Um, Best case scenario, I think in a lot of cases is you're going to be able to repoint base pointer, the saved base pointer.
which might be useful. I don't
Oh,
know
it
because
could be useful because I can imagine if they're doing this on the stack, you've probably got other attacker data on the stack too. But what I was going to get at is this is a certificate. So if there's ASLR, like this is a one
exactly.
and done. So you don't have that chance to kind of ask the question back and forth and figure out where's anything located at. Your certificate that's signed needs to know what value to put in there. Um,
Yeah. See, that's kind of where I was going with like that might be useful is because, you know, you have a 4 byte overwrite, so you're not able to do like a partial overwrite really. You have to write at least a D word. So ASLR is going to be in play there. It's well, I assumingly like maybe there are some cases where it wouldn't be, but if it is, it's going to be really hard to get control of the stack pointer in a useful way that way. Um, so yeah,
though
because like if it was
bootloaders
like
without
a
it, completely
yeah,
believable.
yeah, it's true. But what I was gonna say was like, yeah, if it was like a linear overflow where you had some control of the length and you could terminate it early, absolutely. Like being able to hit RBP like that, you could do something useful. But where this is kind of constrained and you're going to be writing 4 bytes, yeah, it's a bit hard to say. It's going to be very context specific, and I think in most contexts, yeah, it's just not really going to happen. I did want to mention there is also the second bug, which I briefly touched on earlier. That is a little bit it's kind of interesting because it's both a little bit more useful and a little bit more constrained too, because it was basically possible to get the decode handler to keep outputting dot characters past the end of the buffer if you kept passing punycode labels in the email field. It seems they had a bit of code where if it hadn't reached the end and there was still encoded characters, it would write out the dot characters and set the result to 0, but it would never actually check that result, so it could just keep writing the characters. So, you could basically overflow dot characters of arbitrary length on the stack, though only dot characters. So, in this other bug case, you have more control over the length of and how much you're hitting on the stack, but you have no control over the contents. So, yeah, it's kind of like a trade-off. Again, you're in a questionable exploit scenario, but yeah, I mean, they are both memory corruptions, like you said. Maybe there's some useful way you could take advantage of it, but the fact that I'm thinking both bugs. I know at least the one bug that we were talking about is only reachable after the cert validation. It's
they're both
kind
that
of
punycode functions. They're both needing to go through, at least for OpenSSL. Some other if some other things using its library calling in, that's a different case. But at least going through the normal SSL, like not calling punycode directly, it needs to go through that same signature validation and all of that first.
that's what I would assume too. Yeah. Now, I know there was a bit of discussion around these issues and some drama around it because
Yeah,
people were
before
surprised like such a simple issue was found in live code, and I think you want to jump into that, so I'll let you.
I did want to jump into that as kind of a final note on exploitation, though. Um, I do think these issues, like these are the sorts of issues that can be really fun to play around with and try and exploit because we're talking here about all the challenges to it, but it is a memory corruption. It is possible that there is something you can do with it, and it's always impressive when somebody does work out those issues that appear like first glance not to be exploitable. Um, so I just want to show like we're thinking that, but I would never be absolutely certain in saying something's not exploitable, even in a case like this, because it has been proven otherwise before. I mean, I think of the poison null byte attack where off by one null byte right in the heap, eventually they worked into an actual attack effectively to get RC. So
See, that's kind of why I'm a little bit more comfortable saying this one's probably not exploitable, though, is because in the heap you have so much more
you've got
attack
grooming, you've
strategies.
got metadata,
Yeah,
actually, I think would be the big thing there.
yeah, the stack, it's you don't really have the same level of influence, so
Yeah.
it's a lot trickier to hit.
Yeah, definitely. Um anyway, so the other aspect I kind of want to talk about here was there was some discussion regarding how did this vulnerability happen? Why wasn't it caught sooner? And there was a Twitter post um and this blog post that I've brought up here where they basically had what they refer to as actually I think this is a link to the Twitter. Yeah. So I'm just pulling up the Twitter here, but to the simplest possible fuzzing test case, basically, which is just a 4-line creates a buffer, pass or uses libfuzzer, so has the libfuzzer input. Libfuzzer does all like the heavy lifting for actually fuzzing, comes up with inputs and passes them in. They pass that into punycode decode, and very quickly we're able to get this stack buffer overflow. How many iterations did they get here? Yeah, just under
Looks like just
10,000
under 10,000.
iterations. Yeah.
Yeah.
So pretty quick. Able to find it. I think they indicate that was in seconds somewhere in the chain. Either way, a fairly quick and easy to find issue with fuzzing, and there were a lot of indications that OpenSSL just wasn't fuzzing. Remember reading, I think it was Hacker News, where the discussion was like, why didn't they learn from past vulnerabilities, to start fuzzing? And they are fuzzing. OpenSSL does fuzz their code. The main reason why I don't think this one would have been caught super early is, as we've talked about, the way OpenSSL does their fuzzing. I'll just pull up their fuzzer. Also using libfuzzer, although they have a different wrapper around it. Coming in at fuzzer test 1, All they do for their testing though is they do this D2I X509 sir, with the buffer coming in and passing the link there, and they do print some data, and they do I to D with it. Effectively, they just parse they parse whatever buffer comes in as a certificate and fuzz that way. So what they're doing is they're fuzzing all of X509, and their fuzzer, and this is also going through OSS Fuzz, Google's program for fuzzing open source software. They fuzz the entire X509, so in theory, this can hit punycode, but they aren't writing individual fuzzers for every single function that can be hit, which is a good and best practices to write something for that. Current exploit mentions, well, it's pretty lazy fuzzer. I hope they have a decent corpus. Yeah, I believe they do have more of a corpus to this towards actually generating. They have a better wrapper around actually generating. Notice this isn't the live fuzzer test one. It's fuzzer test one input, which is basically after they've done their own wrapper to do like OpenSSL specific stuff. A little bit more complex than it appears. Like they're not just getting a random buffer here. But it is kind of a lazy buffer, but it's testing the entirety of X509 parsing. And not testing that specific function. That's kind of the key thing. Writing a fuzzer for every function is a good practice. It is something companies should do with their software, is having a fuzzer on all of those functions, rather than doing it like this as the whole. But we've also talked about bugs that have been missed because they were only fuzzing those functions and not doing like integrated testing. It takes a lot more maintenance, a lot more effort for them to maintain fuzzers on every single function that's there. So, I mean, I feel like doing this fuzzing is a fair trade-off. It's not the best practice. However, OpenSSL is, I think they only have 2 full-time engineers. Obviously, more people do contribute to it, but in terms of full-time stuff, I think they only have 2 engineers. So, like, this is not a massive project, but, they have to make these trade-offs. And I feel like, they're doing fuzzing, so that's good. OSS fuzzes on it. Again, good. Would be better if they were doing that, and that is, a lesson to learn here is to do the more targeted fuzzing, or basically, I kind of think as a similar case of unit testing versus integration testing. Both are kind of necessary. But yeah, I mean, go ahead.
Part of the problem is to do that like individual testing to try to like maximize your coverage of functions. Like that's typically dedicated to an entire team in and of itself. So it's like it's just not really something they seem to have the resources to do. And like it's very tasking to do that, especially as your code gets updated. Your fuzzers then also have to be updated. At what point does it stop becoming reasonable, right? Especially when you're only talking about a few people. And the other thing I'd mention too is like it's very easy to go after the fact and just like write a fuzzer to try to target a bug and then hit it and then be like, oh wow, they're so stupid. Why couldn't they find this? I mean, we've probably been guilty of this in the past too. It's just very easy with the hindsight to be able to write a fuzzer that can hit something. Whereas, when you're obviously not aware of that issue, and the fuzzer is running, you don't really have a ton of control or influence over what that fuzzer is going to be targeting. It's inherently going to be random. It's going to be based on whatever corpus it has, what it's been building up and coverage on, and whatever. It's going to depend on what kind of instrumentation is in play. In this case, a SAN could catch it, and I'm assuming they're using a SAN with their fuzzing setup. So they could have found it in this case. But yeah, I mean, it feels a little unfair to just like write a quick fuzzer and be like, oh yeah, I was able to hit this issue, but like where the issue is, so of course you're going to be able to target a fuzzer to be able to hit it. You know what I mean?
Yeah, that's kind of
why
I
don't think that's totally fair. Basically,
that's kind of why I've talked about like writing this across every function that's exposed and kind of generalize it out. Because yeah, like they wouldn't know to write the fuzzer on the one, but as developers are writing functions that do get exposed, as they do have man pages for them, as they have those functions, those developers could also write the fuzzer for them as part of like writing, same way you'd write like a unit test for your function. Um,
Even that though,
that's
I could see there being bias. If you're like writing a fuzzer for your own function, you can try to think of it as like, okay, I intend the function to be called this way, so I'm going to fuzz it with that in mind. You know what I mean?
well, this
I
one
feel
at
like
least
even
in
that could have
particular.
problems.
Um, going back, this was the simplest possible fuzzer targeting OpenSSL punycode decode or whatever the function name was. Like
Yeah,
it
sorry,
wasn't
I am being
doing
a bit
anything
general
extra.
there. Yeah,
But yeah,
I
like
am
you
being a bit
can.
general.
You're definitely right. Like you can end up doing that. There can be problems with that, but like that is, I think, the best way to integrate having fuzzing. Is to also have developers in charge of writing the fuzz tests for their functions. Um, you can have that bias there in the same way you can have that bias with anything else, but that's also where, that's where the integration testing should hit it. And I think that's where you kind of have the issue on this one is because of the constraints on actually reaching that punny code um decode, like actually getting that call to happen during the X509 parsing. Because it needs to, go through all the valid stuff. I can imagine that the fuzzer just wasn't hitting that. As far as I know, OSS Fuzz does not publish like their coverage information. I can't actually take a look and see if it was hitting the function at all. Maybe it was always hitting it with valid data or something like that.
Yeah, we are heavily speculating here where we don't know like a lot about their fuzzing setup. So
well, so
um
I do have like the build script. I think that's here actually. That's used by, or was it in OS? I think it might have. There was a oh no, I have the link somewhere. I don't have it up right now. It goes to
yeah,
the actual
but
build script that OSS Fuzz uses to build all of the fuzzers that um, OpenSSL provides. Because they build
yeah,
quite a few fuzzers.
but what I mean is we don't have all the information on like what corpus they have and what coverage they like any of the fuzzer state. So that's kind of where we're speculating. We don't know. It's fair to like point that out.
Okay, I may
Um,
be wrong. Current exploit in chat mentions this was posted on Twitter. Storage report to OSS Fuzz coverage. So maybe they do post coverage somewhere. I was trying to look for and
oh,
wasn't
neat.
finding
Okay.
it, but obviously they have it in, I guess this is just on Google storage, but presumably you might actually be able to see that somewhere, or it was just shared internally. I've
Well, this file has zero coverage, so to save you
so
the
it's
trouble of
not
looking
hitting
through it,
it. Yeah.
yeah, yeah, it's not hitting it
Um,
at all.
Yeah, not hitting anything actually in here, which is interesting. I don't know what the constraints are to hitting this. Because like if that punny code decode is really the main entry point. Um yeah, okay. So yeah, this ATU compare I remember being mentioned in one of the write-ups is kind of what ends up leading to the punny code one. So my guess is basically all of this kind of falls under that same sort of constraint. As we were talking about needing to have the whole certificate true, which in fairness, like if you're looking at this coverage, this is something you can notice and be like, why aren't we hitting this? How can we write a better fuzzer that will hit this? And so
Yeah,
providing like the signed certs and all of that. And if they're not going through with that, they should, as I think it was current exploit also mentioned earlier, like the lazy fuzzing. I believe I recall reading in some of the code, they are doing a little bit more than what it appears that they're doing, perhaps not enough. Because yeah, I mean, if you do read the fuzzer that we looked at, um, so I'm also going to apologize to those of you watching. I opened up the link in my main browser instead of the actual visible one. But yes, you can kind of see it's just all zeros for the coverage report.
yeah. I mean, it's fair to call out, and like you, kind of jumping back to what you said earlier with best practices. Like best practices would be looking at the coverage, trying to improve your coverage across files. But like I said too, like that's typically dedicated to like a team of people that are working on that. So
Yeah, it's a big ask for like the two full-time engineers to do a lot of this. I think they should be doing that. But at the same time,
but realistically,
it's
you're
two
going to be
engineers.
constrained. Yeah.
Yeah, plus free. Like I think it would be a great place if somebody wanted to contribute on the fuzzing side. That is somewhere somebody with one of our listeners, even or somebody with more security knowledge could jump in and like improve the fuzzing and get involved at that level. But at
That
the
would be
same
awesome.
time,
Yeah.
um, at the same time, like for this project, they are chronically underfunded, and it kind of just showcases that they've got fuzzing, they've improved a bit. There's more that could be done, and I think part of the problem really comes down to the fact that these get so widely used, but still rather underfunded.
It's kind of interesting because like OpenSSL seems to be really lacking resources and it's used like everywhere. It's a very heavily used library. And there's this weird thing in open source where it's like certain projects, like let's say the Linux kernel,
In the
the Linux
lottery.
kernel has well, the Linux kernel has funding from like multiple like mega corporations. They've got a lot of like support on that front, which is why Linux security is constantly improving and getting better, and has a lot of tooling built around it, especially with Google. But yeah, with things like OpenSSL, it's kind of just like yeah, nobody seems to care. I don't know why. It would be nice to see more resources thrown at projects like OpenSSL. It seems to be kind of the weak link in the dependency chain where it's like these crypto libraries, it's just like people don't care about them from like a security perspective, which kind of sucks,
Yeah,
and
and
it's why some of these issues prop up.
I think we were kind of privately talking about that a bit, and I feel like part of that might be like there's kind of this feeling also because of OpenSSL's past. I feel like some places are also just trying to avoid using OpenSSL, and thus you kind of have a few competing products out there. It's kind of splitting anybody that might support. And I've just pulled up like their acknowledgments here and sponsorship donations, and yeah, it's a very small list. Like there are companies. I think one thing I saw said they get like $1 million a year. Um, or something like
That
that. So
doesn't go
like,
very far when you're talking about engineers, though.
yeah, no, it doesn't. Like it's enough for some engineers and some infrastructure and stuff, but like I don't know how accurate that number is, by the way. That is like I read that one time sort of thing, so the number could be very wrong. But like, there's literally just a handful of companies actually sponsoring them here.
Yeah. So basically, like the main takeaway from that conversation is just like, it's fair to point out that their fuzzing is a little lazy. They could be doing it better, but it's also fair to point out that their resources are somewhat constrained. Doing this kind of active fuzzing, where you're actively looking at coverage and continuously improving it, as well as doing development, is not a small ask. It's a pretty tall order, especially when you're talking about only a few people doing it. So
Yeah, and it's a
yeah,
huge project too. I mean, we're talking about this one fuzzer for X509 parsing. They also have the ASN1 parser here. I guess actually, I think CMP is some fuzzer, but I'm not sure. Yeah, it is. I just don't know what that is. Actually, it looks like it does more with X509 stuff. I don't know. Either way, it's a large project though. There is a lot of code here. So yeah, I mean, it sucks that it happened. This isn't the worst phone ever. Like they did drop it down to high. I
yeah.
think it could have been caught earlier with better practices, but I kind of am willing to excuse them on that because they're not like the worst practices I've ever seen.
Yeah. And, the where the vulnerability is so constrained, I mean, that's going to constrain the fuzzer's ability to find it too, which we kind of touched on. So, yeah, I mean, there's a lot of circumstances to consider there, basically.
Belika just linked a great comic I had forgotten about from XKCD. Basically, just dependency in modern digital infrastructure, and just it's the one little project that is
The
being
Jenga tower.
maintained. Yeah.
Yeah.
Well, the one little project holding everything off, random person Nebraska has been thanklessly maintaining since 2003. Very
Yeah.
true. I mean, and I've read about that even in companies that like not like OpenSSL. OpenSSL's a little bit different, but yeah, I've read about like teams at Microsoft where it's like, this one person maintaining some core project that everybody's depending on. It's like one person on the team that's doing it. Um I mean, you have a lot of dependencies. Sometimes you don't even notice them.
A
Anyway,
lot of the time. Yeah.
I mean, really, as a vulnerability, I think exploitability could be something interesting to look at. Fuzzing wise, we talked a while back, like an example where the fuzzer wasn't doing this, actually wasn't doing large value fuzzing, like large input fuzzing. So kind of miss things there, but kind of an integration issue. In this case, it's a flip side of being not doing the unit level testing. So I mean, it's interesting for those reasons, but I think we've also talked about everything now.
Yeah, like you said, it'd be cool to see if somebody can come up with an exploit for the Vuln, though. So keep
Yeah,
a
or
lookout for that, I guess.
note the scenarios that it is exploitable in.
Yeah. All right, so we'll jump into our next topic here, which is a Project Zero post by Felix Wilhelm on Vuln and XML signature verification and OpenGDK. So again, kind of another crypto-related parsing bug. And Z, I'll let you jump into this.
Yeah, I mean, yes, crypto relay parsing bug. Not really in the crypto code at all. Uh, this one's cool. So there's actually a hexacon talk. I think it's hacking the cloud with SAML or something like that. By Felix Wilhelm. Um, Pretty good talk. Also, it follows a lot of the same content. The post goes into a little bit more detail. I'm going to summarize a lot of this because it is a long post, and a lot of it is only really going to be interested if you're actually interested in pulling off like this specific attack. Starting this off, a little bit of background with SAML. You've got the what is that? Security assertion markup language, I want to say. Effectively, it's used for like single sign-on systems. You'll pass around similar in a sense, or at least in concept, what it's trying to do in some cases to like OAuth, but way more like options, customizability, and things that can happen in there. And it uses XML to pass around or to write up these assertions. As you would expect, it does signatures, it has signing of the data, all of that. One of the key things that it does is when you have signed information with these XML signatures, it can perform kind of translations or transformations on the data itself to kind of normalize it, canonicalize it. So both sides are comparing the same like data to be signed. And that actually is way more complex than you might expect it to be. That's where this XSLT comes into play, which I forget exactly what that stands for. But it's like a query language, or not a query language. It's like a little language that you can write transformations in. You've got looping, you can call functions with it. Yeah, I just pulled up an example here on W3 Schools where you can basically write like, selecting the title and looping over things that are in catalog/CD and then goes to okay, they've just got the template up here, but effectively it is, you can write kind of somewhat arbitrary transformations here. And so that kind of slows things down. It's almost like a little scripting language that can be applied over the data before the signature gets checked. So what you can do, or what they do, is they actually compile that into a Java byte class, or into Java bytecode, creating a class file of this XSLT, and that's the XSLTC project. Will effectively take this XSLT, compile it into Java bytecode, which is where we have an issue. What it does is, in crafting a Java class file, it has a constant pool. Constant pool contains things like, all of the constants that are being used, functions are in there, or in some cases, I think you'll have function and a pointer-ish things in there. I don't know everything that's in there. Either way, it's critical data for the class. The class is going to reference these things. You've got the constant pool count, and then you've got the actual constant pool, which is just basically the constant pool entries one after the other. And the problem is that the constant pool count is a U2, or basically unsigned integer of 2 bytes long, or a 16-bit integer, I guess. got that count for that, but the way it tracks it internally is it only uses or it uses just the standard Java array to track all of these constants that's adding to the pool. And so you can overflow this. If you have more than 16 bits worth of constants, it's just going to overflow and you're going to have more constants, but the actual constant pool or count value that gets written out is going to be very small. So it might say you have like 2 constant pool entries and you've got like the 2 indices written there. But when it goes to write them, it's going to write like all, what is it for 16 bits? 65,000, I think, values.
Yeah, sounds right. Yeah.
Yeah. Well, like 65, 565 or
536 or whatever, yeah.
Yeah. It's a bunch of 6s and 5s. Oh.
That's all I remember. Yeah.
Yeah, pretty much.
65, 535. There you go.
Yeah, okay. So but yeah, it's going to write all of those entries out because it knows about them as it's writing it. But that integer, I guess I say overflow, it gets truncated at technically. Because there's too many. So when the actual class gets executed and run to perform the transformation, what will happen is it's going to basically misparse. It's going to think that things that are that were written, it was thinking that's part of the constant pool that the BCEL, the library that actually does this, it thinks it's writing constant pool values, but because that constant pool count is so low, it's going to start, or the Java environment is going to start reading as the access flag, this class, super class. It's going to start reading as all of these things, and misinterpreting all of that data, basically letting you craft a class to get arbitrary code execution. That's where kind of the rest of the post goes down into how these different pieces of constants get transformed into the bytecode, and that sort of translation, how you're able to craft specific things, some of the challenges involved there. It is interesting. It reminds me of something we talked about quite a while back. I'd have to find the link to the post. It was another like Java bug, but it was I think Google's App Engine.
I can't really remember the post you're talking about, unfortunately.
Yeah. I meant to look it up before. Sorry, but it was like a intern at Google, or maybe it was Amazon or something. They were doing a Java rewriting thing to sandbox it, and they found like this crazy bug in there, and they started kind of trying to craft the bytecode using this overflow. I'll see if I could find the link later and just add it to our show notes, but mind me a bit of that. I don't want to dive too much into that because unless you're going to be crafting like this bytecode and trying to do this yourself, you're probably not running into that same situation. But that integer truncation, definitely happens in more cases than just this. And it's kind of fun because this is a unauthenticated attack surface. This is, SAML is coming through and being passed around through the user. So the user can break these things. Out of chat, XCD80S is a deserialization. No, it's not a deserialization bug. You can craft a custom, like you're basically getting control of the bytecode of the Java class itself. You have some constraints over how the data is formed just because of the fact that the actual creator thinks that it's these constant pool entries. Like you're writing the bytecode that the Java virtual machine understands. If you're not familiar with bytecode, as this is our binary episode, most people are going to be familiar with what machine language is. Bytecode is similar to machine language, except it's intended to run in a virtual machine or like by another piece of software. So the Java VM runs Java bytecode. It's generally like it's higher level than actual machine code. Like it has like the concept of a function and stuff rather than just like jumps and branching. Has like these higher level concepts built in, so it is nicer to work with. But you're effectively able to craft that higher level bytecode to get relatively arbitrary code execution here. So not quite deserialization, but still leading to RC.
Yeah, it's kind of cool how this bug even works, and like the primitive that you get off of it for being able to, overwrite the other class members. I don't know. It's just something that I don't think we see very often in like a Java vulnerability scenario, because it's almost got like a memory corruption-esque feel to it, um, where you just don't really see that in the Java vulnerabilities we cover. So yeah, as is always the case too, with these Project Zero posts, Post is very thorough and does a good job of like showing, giving you all the relevant code snippets and doing some diagrams to help illustrate what they're talking about, especially in the exploitation section. But yeah, like you said, I think it's fair to, if you want to check that out, it's there. Go for it. But we're not really going to cover it because it's pretty hyper specific to this exploit scenario. So yeah, there is also the Hexacon talk on it. I haven't watched it yet. I don't know if maybe we'll cover it in our watch parties, but regardless if we do or don't, I'll probably check out this talk as well because yeah, a lot of the Hexacon talks were pretty cool, and it's
Imagine what
it's
would
interesting. We've already had like 2 talks tie into our topics already.
At 6TERRA,
So,
we're focused on building
yeah, just goes to show, I guess, how
my
relevant some of those
apologies.
Hexacon talks are on the
Some people
stuff.
might have heard some random audio while you were on there. I was trying to add the YouTube video and had an ad playing right off the start. So sorry about that.
Oh, okay. Hopefully,
You can
most
repeat
of
the
what I
last
said was
few
said.
seconds.
Yeah, no, I was just saying, with it's cool because Hexacon, we've had like 2 Hexacon talks that are relevant to the topics we've been covering, so just kind of illustrates like how relevant the stuff that was talked about at Hexacon is to the modern landscape for vuln research and exploitation. So yeah, along that lines, we have another Project Zero post, which is by Maddie Stone on an in the wild exploit chain found targeting some Samsung devices using 3 vulnerabilities. And interestingly, the sample they seem to have got, they believe was leaked as like part of a debug build. So it wasn't like a production ready productized thing where there was like a payload at the end of it. It was just kind of the implementation of the exploits. So yeah, three exploits were involved here. It consisted of a file rewrite in the clipboard provider, a kernel info leak through seclog, and a UAF in the display processing unit or DPU driver. This was targeting some older Samsung devices running 4.14.113. Lower, or lower rather, for the kernel version, and it was targeting Exynos devices specifically, so international Samsung models, not the North American ones. So yeah, jumping into it, first vulnerability, the arbitrary file system read write. This one was kind of neat in how it worked, and it's probably the most interesting issue in the post. But it's also fairly simple. And it's basically like an access controls issue in Samsung's custom clipboard provider. So this was accessible over the system server. The clipboard content provider, I believe, is supposed to be used for like images here. So it'll have like a database which has a table of IDs to this underscore data value, which is used to store the URI of the file, the backing file to open. The problem is there's basically no validation on that URI. And there's no permission checking on the calling process against that URI. So you can basically just insert arbitrary URIs into the database with the insert method on the clipboard content provider. So yeah, by just passing a path to some privileged file, you can basically use the system server as a proxy to get a raw file descriptor to a file that you normally wouldn't have access to. From there, they use that a couple times in the exploit chain. The first thing they do is use that to install a backdoor executable in the data systems user 0 directory, and then it uses it as to access the other components that are used for the kernel vulnerabilities too. The post details a bit about how they escaped the sandbox by utilizing Samsung's text-to-speech combined with the first vuln. So basically, what they did there was they used the clipboard to write to the text-to-speech settings, and they set the like engine path to the file they installed earlier. So that gets them arbitrary code exec as system in the system app SE Linux context, which is pretty important because the kernel vulnerabilities were only accessible to the system app context, like they weren't accessible to unprivileged. So they talk a bit about that, but that in and of itself is basically just how they took advantage of the exploit to continue on to the next stage. Wasn't really a vulnerability in and of itself. The second vulnerability was in the kernel log component that Samsung has, which is also custom. Basically, Samsung has this custom logging file, data log seclog, and that file was accessible to system app. And where kmessage is normally privileged off, even from system app, because obviously there could be some sensitive data going there, Samsung's custom logging utility would basically copy kmessage contents over to the sec log. So if you could just trigger a warning or anything else that would dump the register state to the logs, you could just use that to leak kernel pointers. There, they used a warn on in the Mali GPU driver, where on affected devices, if you just simply provided a bad hardware count reader IOCTL, it would call warn on, and then the pointers will be dumped to the stack, and you've defeated KSLR basically. The third and final vuln was a UAF in the DPU kernel driver, which could lead to arbitrary read write. That was in the decon set win config function for the display and enhancement controller. Pretty straightforward UAF. Basically, this set win config function would try to create a DMA fence and install a file descriptor for the retire fence sync file. Now, we've kind of covered an issue that was similar to this before, but for those that don't know, in the Linux kernel, when you call fd install, that's basically creating an fd and installing it in the process file table. So as soon as that call executes, anyone in the process can access that file descriptor and do operations on the file, such as closing it, for example. So yeah, an attacker can get access, close it, but at that stage, a reference isn't taken on the file, and they use that file to install another file descriptor for the relative fence field. And yeah, so if an attacker can just close it in between when those two files are installed, it could end up installing a free or dangling file pointer, and yeah, you now have a free file struct with a controlled FD available to the attacker. Post does get into some of the exploitation there, which was sort of the classic attack for getting read write when you have an arbitrary write, which was going after the address limit. That's basically a field that's used by the kernel to determine whether you're doing a kernel or user access. So to try to prevent you from writing directly to kernel memory with like a copy in call or something. Yeah, so what they did here was they used the file's private data pointer, wrote that to set it to the address limit, and then used signal FD to perform the write. There is a little bit more to it than that. They actually set the address limit multiple times to either the kernel DS or the user DS, or the kernel or user address limits, rather. And that was to get around like the user access override and privileged access never mitigations. I won't go too much into that, as that's getting fairly specific. But Maddie says that she also doesn't consider this a bypass because like UAO and PAN aren't really meant to protect against a scenario where you have an arbitrary write access to address limit. This technique is basically just abusing how UAO and PAN are intended to be used. The attacker is basically just toggling the address limit as if they were doing a regular proper user kernel access. Finally, after getting read write, they escalate credentials and set their process SC Linux policy to Vold, which is the volume daemon, which is basically like the most high, one of the highest privilege contexts that you can have. But yeah, awesome write up by Maddie Stone here. It does give a lot of insight into Android and what's involved in some of these in the wild chains. And shows the process of like escalating throughout the phone to get access to more and more attack surface, exploit more and more vulnerabilities to finally get what's essentially root. Yeah, I think it does a really good job of showing like sort of what's involved in like cutting edge Android exploitation. And obviously, this was in the wild, so that's exactly what it is. But yeah, I think the post does a really good job of breaking it down, even if you're not familiar with Android and its complicated permission model. It's pretty like navigatable. You'll be able to understand this blog post pretty well, and it goes into detail on like exactly how these vulnerabilities were taken advantage of to continue escalation. So yeah, really good post by Maddie Stone. Pretty interesting vulnerabilities. Like I said, I think the most interesting one is probably the clipboard provider, where they basically just like get access to privileged files, getting raw file descriptors by abusing the system server as a proxy. I
By
thought that was
just
kind of
asking
neat.
for them. They
Yeah,
give privileged files by just asking for them, basically. Yeah, I thought
one of
that
those
was a fun
exploits where
one
it's pretty
here.
reliable.
Yeah, I agree with you. I think that was kind of the more fun issue out of the rest. I mean, kernel leak through the sec logs is um I mean, the fact that it's basically just copying it out into the log file, sensitive data, like that's kind of another funny issue to see here. But getting the file because you ask for it is pretty fun. So, and
Yeah.
use after free, I mean, that's standard fare for what we cover.
Yeah. Malika is talking about the phone models, so saying, I feel like Google looks at Samsung lately so much because they make the Pixel in 6 and 7 too. Um, well, Google, like this is from their Project Zero's like in the wild analysis, so it's not really. I think this is actually the first time I've really seen them cover Samsung. I mean, maybe they've covered it before, but they just cover like whatever they come across really.
They've covered it. Like I do remember the QMage stuff a while back. Someone at P0 fuzzed like that image Skia library, I think it was, which I believe is a Samsung thing, or at least being used on Samsung, and had like thousands of bugs falling out of it. So
Yeah,
like they've looked at Samsung before. It's come up, but I don't know. This
yeah,
one specifically comes out of like an in the wild, but I don't know. I mean, that would make sense as a motivation, but I'm not sure how much they really push on the Project Zero members versus just letting them put their time where they think it would be useful and at what they want to look at versus using another team for that.
yeah. Something else I wanted to comment on is Beliga mentioned Pixel 7 is the most secure Exynos-based phone you can buy now. Pixel 7 isn't using Exynos as far as I know. Pixel 6 and 7 are using Google's custom Tensor SoC, which is like an in-house SoC they've been working on. Um, so yeah, I don't think Pixel is using either Qualcomm or Exynos. But yeah, that's another thing that's interesting with Samsung. Actually, is like as far as I know, other vendors don't really do this, where they use like a different SoC between their US models and their international models. But Samsung, like you'll only find Samsung Qualcomm phones from like US vendors, whereas their international models uses Exynos, which is like a less powerful SoC. I've always been kind of like curious what the reasoning on that is. It's a little bit weird. It's also like pretty annoying because Samsung, the Qualcomm devices are a lot more locked down. So doing security research on them is a lot more difficult, whereas the Exynos international devices are fairly open. You can unlock the bootloader and everything pretty easily. Uh, you still do lose some things if you flash the phone, like you'll lose the Samsung Pay or whatever, which is like who cares? I don't even know if anyone uses that, but yeah, Samsung's kind of weird with how they divvy up the SoCs in their phone models. Um, so it was kind of cool to be able to comment, like see that in action here too, and comment on that a bit. But yeah, um, Beliga said no, they are Exynos Tensor as a rebranded Exynos 9845. Okay, fair enough. I don't know too much about like Google's Tensor SoC. It's not something I've looked at really. It wouldn't surprise me that they based it on an existing thing. And I think I recall seeing that Google did use Samsung Fab for the Tensor cores. So yeah, using Xenos would kind of make sense there, I guess. But all right, fair enough. Good point. But yeah, getting back to the post, like I said, I think it's a pretty good post. It is a little bit long. It goes into a lot of details. Um, you may want to jump to like a specific section. Post's pretty laid out, so you can do that easily. But yeah, cool chain here, showing escalating through userland to eventually hit kernel and get root. So wanted to give it a shout out, and yeah, that's pretty much everything I had to say on that. So
Yeah.
unless you have anything you want to add, Z, I guess we'll move on to shoutouts and wrap up the show.
No, I'll move right into the shout outs there where I just had the one shout out. Um it's a symbolic triage, making the best of a good situation. I haven't done a lot with symbolic execution. I'm familiar with it, use it in like a couple situations, but I thought this was a cool post, just basically talking about their process going through using some symbolic execution to triage a bunch of fuzzing results or a bunch of crashes reported by a fuzzer. Goes right into their process there, everything they're trying, starting off with just creating like a little debugger so they can pull kind of concolic execution where they have concrete information, executing a bit symbolically. Oh, I thought it was a cool post for that. Dives into that and shows off some reasons to be using symbolic execution, how you might integrate it into your workflow. Apparently, they also have like a 4-day course, so you can check that out too if you're actually interested. But as an initial post, it actually did kind of intrigue me a bit to maybe look at it a little bit more. I just haven't really put the time into it myself, but kind of show some reasons to instead of sticking with just the traditional ways, I guess. So yeah, wanted to shout it out.
All right, cool. So that's where we'll end off the show. Thank you, everyone who tuned in. You can catch the bot on Twitch immediately or on other platforms like YouTube tomorrow. Previous podcasts can also be found on Spotify, Apple Podcasts, and more links on Anchor. Feel free to join the Discord and follow us on Twitter. Links for those are in the chat or down below. And once again, keep a lookout for our DEF CON talk coverage on Thursday and Friday. And we'll see you then.